All right, so today we're going to talk about limiting reactants. So I just wrote a few things about limiting reactants here. For these types of problems, you're going to be given information on more than one reactant. I've got an equation on the board, so you can ignore all this. Equation on the board, we've got one reactant, another, and two products. So these would be cases where you're given information about both of these reactants, and you need to determine which reactant gets used up first. So the reactant that does run out first, we call that the limiting reactant. Then we're going to have an excess. Oh, there you go. We will have the leftover, and the leftover, that whatever that is, whatever that substance is, we call that the excess reagent. So those are a couple terms that you want to be able to use. So I wrote down a problem. We got 0.417 grams of aqueous silver nitrate. You can see aqueous silver nitrate here are combined with 0.220 grams of aqueous copper 2 chloride. You can see that. First question you should be able to answer is, what is the limiting reagent? So I worked it through here. I started with the 0.417 grams of silver nitrate. I converted to moles using the molar mass. Then I used the stoichiometry step, right? These numbers come from the coefficients in the equation. So we have 2 moles of silver nitrate that are going to react with 1 mole of copper chloride. So all I'm doing is saying, okay, if I have 0.417 grams of silver nitrate, how much copper chloride would that react with? That's the question this whole line in red is going to answer. So convert to moles of silver nitrate, then to moles of copper chloride, and now we use the molar mass and convert to grams, and we get 0.165. So anytime you do a calculation, make sure you're understanding what the numbers mean. This means 0.417 grams of silver nitrate will react with exactly 0.165 grams of copper 2 chloride. Next thing, I'm going to take the copper 2 chloride. We're told that we have 0.220 grams. So I want to know, well, how much silver nitrate will this react with? So I do the same thing. I'm going to convert to moles using the molar mass of copper 2 chloride. Then I convert from moles of copper 2 chloride to moles of silver nitrate using the coefficients 1 to 2. And then I convert to grams of silver nitrate using the molar mass, and I get 0.556. So then we need to look at these numbers and see what they tell us. You can kind of see right away. To react 0.220 grams of copper 2 chloride, we need 0.556 grams of silver nitrate. But we don't have that, right? So this isn't going to happen, right? This is not all going to react. To react 0.417 grams of silver nitrate, we need 0.165 grams of copper 2 chloride, and we do have that. Right? So to answer the question, what's the limiting reagent, which one is going to fully react, the answer is the silver nitrate is the limiting reactant or reagent. That means the copper 2 chloride will be the excess reagent. So that's the first question, and it's silver nitrate. Make sure when you're answering limiting reagent questions, you always pick something on the reactant side. Sometimes people pick, no, it's a reactant. Then question number 2. How much excess reagent is left over? So we started with 0.220 grams of copper 2 chloride. That was in the problem. We calculated that the silver nitrate would react with 0.165 grams. So we just subtract. So there's going to be 0.055 grams of copper 2 chloride that do not react. That's left over. And I have something here just to show you what it looks like. So copper 2 chloride looks like that. It's blue. And silver nitrate looks like that. Silver nitrate, copper 2 chloride. So we got these. And if we combine them, we are going to expect, taking a look at the reaction, we see aqueous and we see aqueous. So anytime you look at a chemical reaction, try to think of what it actually looks like. And so you should see something that's clear if it says aqueous. And these look clear. But if we look on the product side, we see one substance that's aqueous, but the other substance is solid. So we're going to expect that we're going to see some cloudiness to it. So I just take you see it mixing there. It gets pretty cloudy. So that's the solid forming. If you let that sit, it'll settle to the bottom, and you end up with something like this. Maybe you can't see it. There's a little bit of a bluish tint to it. The copper ions are still in solution. They're aqueous. All right, those are 2 questions you should be able to answer. A third question is how much precipitate is formed. So I rewrote the equation. How much precipitate is formed? I just ignored the fact that I already knew the limiting reagent, or limiting reactant, and the excess reagent, and I just started with the copper 2 chloride, and the silver nitrate, same as if I was starting over. Now what I'm going to do, since it says precipitate, I'm looking for some solid product that's going to be formed. That's the silver chloride. So again, it's going to look pretty similar. I have a mass to moles conversion, a moles to moles conversion using the coefficients in the equation. 2 to 2, right? It's right there. And then moles to grams for the solid that should be produced. And we do the same thing with the copper 2 chloride. The moles, moles to moles, moles to grams. And we see this. What you're going to find is that when you have a limiting reagent problem, you get 2 different answers. The answer is the lower one, right? You have enough of this reactant to produce this massive product. You have enough of this reactant to produce this massive product. So this you can produce this. Anyway, this is how much precipitate is going to be formed. Okay, so those are 3 questions you should be able to answer. So if you can do this, you should be able to answer this. It's iron 3 nitrate, sodium hydroxide. We got a 1 and 3. What is the limiting reactant? How much excess reagent is left over? And how much precipitate will form?
Good luck.